So, up at the top, we have simplifying radical expressions. If a variable is even, then we know if it's even and becomes odd, we need absolute values. So you can see those absolute values in the y to the 10th example, in the a squared example. Yes.
For number 6, for like the square root of why would you have absolute values around because if it starts out negative, hopefully you don't have to.
And number 6.
Yeah, like that one.
Oh, that number 6. I was looking up at this number 6, and I was like, what? Yeah, you wouldn't need them. It's really delayed. Okay. Thank you for that. Any other questions on any of those? Yep, which one?
This is the first number 8, 81 and 64. Why? So you can't take this square root of 64 and make it like 8. You have to go through.
Correct. So exponents under a square root get divided by 2.
Okay.
And that's it. So like once you do the first divided by 2, you're done. And same with like even your numbers. Like once you took the square root of 81 and you got 9, we don't take the square root of 9 again to get 3.
Okay. So just because it's in the perfect square, I can't get 8 out of it.
Correct.
Thanks.
You're very welcome. Yep.
So I have a question about like number 9 and number 5. So it's just the x cubed. Why are there absolute values there if it's going from?
There shouldn't be. I feel like I went back one time and just put absolute values yesterday.
Okay.
I have like a brain fart in that section. That's only if it goes even, odd.
Okay. I just wanted to make sure.
No, you're good. My poor little worksheet. Got water on it. Okay, and then at the bottom, you had the answers to the odds. I have the answers to the evens. And then 21 was kind of like factoring and simplifying. And when you factored, you saw both had x plus 9, so they canceled, leaving you with x plus 7 over 2x plus 1. So just going back and reviewing the factoring that we talked about last week. Okay, and then simplifying your i's. And then simplifying square roots with negatives. Good.
My number 8 doesn't match it. Mine went to the 2/3 one. I just.
You mean like your problem is different or your answer is different? So are you this one? And I'll redo your handout. It looks like you're just a little off from mine. I did make adjustments for your group to like match the newer curriculum and match because like you guys didn't have this stuff yet. So we'll go over it tomorrow. I's get combined with i's. X, just like x's, combined with x's. So you add the coefficients and combine them. The power of the variable will not change. So in number 9, we would distribute our negative. So you would have 3 plus 6i minus 4 plus 8i. Then you would combine your 3 and your 4 to get negative 1, and your 8 and 6 to get 14i. So that we have our real plus imaginary. We do the same thing in 10, distribute our negative. Combine like terms. So 6 minus I. In number 11, there are no like terms with I. So you combine your values of 7 minus 3 to get 4. So we get 4 minus 2I. And in 12, you have 4 minus 6i plus 3i. Combine your i's and you get 4 minus 3i. Okay. Next, we're going to look at multiplying. So we want to find the product of each term. Now, when you multiply, the power of I does change. So 3i times 8i would become 24 I squared, but I squared is negative 1. So 3i times 8i is negative 24. In number 12, you would multiply your 12 and your 7. You get I squared, change I squared to negative 1, and you get negative 84. So the product of two i's becomes a real. The product of two i's becomes a real. In 13, that I is being squared on the outside as well as the 3. So that's really like 2i times 3i times 3i. So it's 2i times 9i squared, or 18i cubed. And we know I cubed is negative I, so we get negative 18i. Similarly in 14, that's 5i times negative 2i times negative 2i. So when you have the squared on the outside, it's important to know you have to square the numbers as well. So you get 5i times 4i squared, or 20i cubed, which is negative 20i. And then in 9 and 10, we have 3 minus 7i times quantity 2 minus 4i. So now you have to apply your techniques from algebra. You have to do first, outer, inner, and last, combine like terms and change I squared, I cubed, etc. So it would become negative 28. So you get negative 22 minus 26i. Similarly in 14, and you get 9 minus 38i. That leads into the last part of the lesson, which is a complex conjugate. A complex conjugate says that the original is a plus bi. The complex conjugate is a minus bi. It is different than the additive inverse in that the a value isn't changing. Only the complex part of the problem. So it's different from an additive inverse. The product of a complex conjugate will always be a real number. The product of a complex conjugate will always be a real number. So we do not like to have denominators that have i's in them. So what we need to do is in examples like 11 and 12, we have to multiply by the complex conjugate of the denominator on top and bottom so that my denominator no longer has an I. So in the mathematics world, you cannot have an I in your denominator. The complex conjugate is like a factored difference of squares so that the middle terms always cancel each other out. So that the middle terms always cancel each other out. Change your I squareds, clean up your terms. So I squared times negative 12 gives 12 plus 6i in the numerator. And my denominator will become 9 minus 36 because I squared becomes negative 1. So you get negative 36 plus 9, which is negative 27. You could divide everything by 3. And that would reduce to 4 plus 2i over negative 9. But if you're going to simplify, you have to make sure you simplify every part of the fraction, not just like the 12 and the 27 or the 6 and the 27. Every piece has to be divisible by that 3. And then down at the bottom, we have 4 plus I over 5i. The complex conjugate of this problem is simply the opposite of the denominator because there is no real part. So we're going to multiply by negative 5i. So that will give me a negative 25i squared. But we know that I squared becomes negative 1. So that will change my denominator to a positive 25. And I squared up top becomes negative 1. So negative 1 times negative 5 would give me positive 5 minus 20i. And once again, if you wanted to clean that up or simplify, you could divide everything by 5 to get 1 minus 4i all over 5. So last week we looked at solving equations using the square root property. This time we're going to look at solving equations using that same property. However, now when we go to take our square roots are not going to be positive. So we would subtract over 54, divide by 9. So you'd get x squared equals negative 6. And we know that when we have an x squared, we take a square root. And now, instead of saying no real solutions, we know that if we have a negative under our square root, it comes out as an I. So in the case of this problem, x equals plus or minus I square roots of 6. And the plus or minus come from the fact that anytime you take a square root, we need a plus or a minus. So 3x squared plus 48 equals 0. Subtract 48 from both sides. Divide by 3. And we get x squared equals negative 16. So we square root both sides. And we get x equals plus or minus negative 16. So we know that the negative is going to become an I. And 16 is a perfect square. So my roots are x equals plus or minus 4i. So these are actually the type of quadratic equations that are shifted up and down, and they don't cross the x-axis, but they still represent a parabola. So when we looked at them, we said they had no real roots, and that's because they have imaginaries. So we get x squared equals negative 30. When you square root both sides, always put your plus or minus and take out your I. And then you have to look at and see, okay, would 30 simplify? So 30 is 5 and 6, 3 and 10. So the prime factorizations of 30 are 5, 2, and 3. So since there's no like terms among them, this becomes x equals plus or minus I square roots of 30. And I know it seems like a big number to have under a square root, but there's just nothing we can do to simplify it. And then last but not least, we have 8x squared plus 2. So you get 8x squared equals negative 2. So you get x squared equals negative 2 divided by 8. But we know that that's really negative 1 divided by 4. So you get x equals plus or minus the square root of negative 1/4. But if you apply our rules, you could take the square root of the 1 and the 4 separately. So that's really like plus or minus I. And then square root of 1 is 1. Square root of 4 is 2. And it doesn't matter if the I comes before the half or the half comes before the I. I will have a tendency to write it as plus or minus 1/2 I. But again, multiplication is commutative. So the order with which you list the terms doesn't matter. Okay? And then the last question is really about balancing the scales. So you have 3x minus 5 plus y minus 3i equals 7 plus 6i. So we know that in order for two equations to be equal, they have to be the same on the left and on the right. So we are trying to find what value of x and what value of y would make these equations the same. So what you do is you set the real equal to the real. And the imaginary part equal to the imaginary. So that x is 4 and y is 9. So I should be able to plug 4 in for x. So you get 3 times 4 is 12. 12 minus 5 is 7. So the left side matches the right side. Okay, that will finish your packets. Those need to be uploaded tomorrow by 10 a.m. So what we did yesterday and what we're doing. So what we did yesterday was on Khan Academy. That is also due tomorrow at 10 a.m. So if you haven't finished that, that's due tomorrow at 10 a.m. Some of them were, you had to be careful about your absolute values because they told you the values were always positive. And just make sure about how you plug them in. And then this handout will be due tomorrow at 10 a.m. as well. So I am going to adjust. I'll give you the answers to the homework that matches in your packet tomorrow as well. We'll go over day 1 and day 2 both.